NENOMATICA, where mathematics meets YouTube excellence. Exponential equations. Welcome to our mathematics tutorial. Today, we'll be solving an exponential equation step by step, following a specific approach that transforms the original equation into a simpler linear form. Let's start with our problem. We have an exponential equation that states, left parenthesis, 1/2 right parenthesis raised to the power of x, multiplied by left parenthesis 1000 over 125 right parenthesis raised to the power of 4 minus x equals 0.0625. Looking at our problem, we first want to simplify the second fraction. Let's rewrite 1000 over 125 as 10 cubed over 5 cubed. This makes our equation 2 to the power of negative x multiplied by 10 cubed over 5 cubed, all raised to the power of 4 minus x equals 625 over 10,000. Now, we'll simplify the left side of our equation. We can write 2 to the negative x power as 2 to the minus x. And we can expand the second term to 10 cubed over 5 cubed, all raised to 4 minus x. On the right side, we've simplified to 5 to the fourth over 10 to the fourth. Let's continue simplifying. On the left side, we now have 2 to the minus x power multiplied by 10 over 5, raised to 12 minus 3x. On the right side, we still have 5 to the fourth over 10 to the fourth. Now we can further simplify the fraction 10 over 5. 10 over 5 equals 2, so we have 2 to the minus x power multiplied by 2 to the power of 12 minus 3x equals 5 to the fourth over 10 to the fourth, which is also equal to 1/2 to the fourth power. Let's continue. We can simplify 5 over 10 to 1/2. So our equation becomes 2 to the minus x multiplied by 2 to the 12 minus 3x power equals 1/2 to the fourth power. Now, we'll combine the exponents on the left side. Using the properties of exponents, 2 to the minus x power multiplied by 2 to the 12 minus 3x power equals 2 to the power of minus x plus 12 minus 3x, which equals 2 to the power of negative x plus 12 minus 3x. And on the right side, 1/2 to the fourth equals 2 to the negative fourth, as 1/2 equals 2 to the negative 1. Continuing our simplification, on the right side, 2 to the negative 1 raised to the fourth power equals 2 to the negative fourth. So we have 2 to the negative 4x plus 12 equals 2 to the negative 4. When we have the same base on both sides of the equation, we can equate the exponents. This gives us negative 4x plus 12 equals negative 4. Now we solve for x. Subtracting 12 from both sides, we get negative 4x equals negative 16. Finally, dividing both sides by negative 4, we get x equals 4. This is our answer. Let's verify our answer by substituting x equals 4 back into the original equation. When we substitute x equals 4 into our original equation, the left side becomes 1/2 to the fourth power times 1000 over 125 to the power of 4 minus 4, which is 0. 1/2 to the fourth is 1/16, and any number raised to the power of 0 is 1. So we get 1/16 times 1, which equals 1/16 or 0.0625. Here's our exponential equation. 2 raised to the power of x plus 2 equals 16 plus 2 raised to the power of 7 minus x. First, we'll rewrite this using the laws of exponents. We can express 2 raised to the power of x plus 2 as 2 to the power of x times 2 squared. We want to eliminate the exponents with x, so let's multiply both sides by 2 to the power of x divided by 2 squared. This will simplify the left side of the equation. Now we can simplify. On the left side, 2 to the x times 2 squared divided by 2 squared equals 2 to the 2x. On the right side, we distribute and get 4 times 2 to the x plus 2 to the 5. Rearranging the equation, we get 2 to the 2x minus 4 times 2 to the x minus 32 equals 0. Let's substitute a equals 2 to the power of x to make this clearer. After substituting, our equation becomes a squared minus 4a minus 32 equals 0. We can factor this quadratic equation. It becomes a minus 8 times a plus 4 equals 0. By the zero product property, either a plus 4 equals 0 or a minus 8 equals 0. This gives us two possible values for a equals negative 4 or a equals 8. Notice that in the first case, we get 2 to the power of x equals negative 4. Since 2 raised to any power is always positive, this solution is impossible. So we reject this value. Therefore, our only valid solution is from the second case, where we have 2 to the power of x equals 8, which gives us 2 to the power of x equals 2 cubed. Comparing exponents, we get x equals 3. Let's verify our answer by substituting x equals 3 back into the original equation. On the left side, we have 2 raised to the power of 3 plus 2, which is 2 to the 5th power, or 32. On the right side, we have 16 plus 2 raised to the power of 7 minus 3, which is 16 plus 16, or 32. Since both sides equal 32, our solution x equals 3 is correct. Here's our example problem. We need to solve the exponential equation. 5 raised to the power of x minus 1 plus 7 equals 632. Step 1. Let's isolate the exponential term. To do this, we subtract 7 from both sides of the equation. So we get 5 raised to the power of x minus 1 equals 632 minus 7. Step 2. Let's simplify the right side of the equation. 632 minus 7 equals 625. Step 3. We need to recognize that 625 is actually 5 to the 4th power. This will help us solve the equation by comparing the exponents. Step 4. Since we have the same base on both sides of the equation, which is 5, we can set the exponents equal to each other. So x minus 1 equals 4. Step 5. Now we just need to solve for x. We add 1 to both sides of the equation, and we get x equals 5. Our final answer is x equals 5. Let's verify our solution by substituting it back into the original equation. 5 raised to the power of 5 minus 1 plus 7, which is 5 to the 4th plus 7, which is 625 plus 7, equals 632. So our answer is correct. To summarize, when solving exponential equations where we can isolate the exponential term, we use these key steps. First, isolate the exponential term. Second, express any constants as powers of the same base if possible. Third, compare exponents when the bases are equal. And finally, solve for the variable. This approach works for many types of exponential equations. Thanks for watching. Let's look at this example. To solve this exponential equation, we need to isolate the expression containing our variable. Step 1. Let's move 7 to the right side of the equation. Using the rule that we can isolate the variable term by subtracting values from both sides, we get 5 raised to the power of 5 to the x minus 1 equals 632 minus 7. Step 2. Let's simplify the right side of the equation. 632 minus 7 equals 625. Step 3. Now, let's try to express 625 as a power of 5. You should recognize that 625 equals 5 to the power of 4, since 5 to the 4th equals 5 times 5 times 5 times 5, which is 625. So our equation becomes 5 raised to the power of 5 to the x minus 1 equals 5 to the 4th power. Step 4. Since we have the same base of 5 on both sides of the equation, we can set the exponents equal to each other. This is a key property of exponential equations. If a to the power of m equals a to the power of n, then m equals n. So 5 to the x minus 1 equals 4. Step 5. Now let's solve for 5 to the x. Adding 1 to both sides, we get 5 to the x equals 4 plus 1, which is 5. Step 6. Simplifying further, 5 to the x equals 5 to the power of 1. Step 7. Finally, we can again use the property that if powers with the same base are equal, their exponents must be equal. Therefore, x equals 1. We've successfully solved the equation. Let's review what we just did. We started with the equation 5 to the power of 5 to the x minus 1 plus 7 equals 632. We moved the constant term, subtracted. Let's begin with our example problem. We need to solve the following exponential equation. 4 times 2 to the power of x plus 2 times 2 to the power of x minus 2 plus 2 to the power of x equals 22. Let's solve this step by step. First, let's try to get all terms with similar bases. We can rewrite 2 to the power of x minus 2 as 2 to the power of x times 2 to the power of negative 2. Since 2 to the power of negative 2 equals 1 over 4, or 1/4, we get this expression. Now, let's factor out 2 to the power of x from all terms on the left side of the equation. We get 2 to the power of x times the quantity. For plus 2 times 1/4 plus 1 equals 22. Let's simplify what's inside the parentheses. For plus 2 times 1/4 equals 4 plus 1/2, which is 4½ Adding 1 to that gives us 5½ or 11/2. Now, to solve for x, we'll divide both sides by 11/2. On the left side, we have 2 to the power of x equals 22 divided by 11/2. To divide by a fraction, we multiply by its reciprocal. So, 22 divided by 11/2 equals 22 times 2/11. Now, let's simplify this expression. 22 times 2 equals 44, and 44 divided by 11 equals 4. So, 2 to the power of x equals 4. Now, we need to solve for x. Since 2 to the power of x equals 4, and we know that 4 equals 2 squared, or 2 to the power of 2, we can write 2 to the power of x equals 2 to the power of 2. Finally, since the bases are the same, the exponents must be equal. Therefore, x equals 2 is our solution. We have the exponential equation. 3 times 3 raised to the power of x plus 2 equals 9 times 2 raised to the power of 5x plus 5. Let's start by dividing both sides by 9. On the left side, we get 3 divided by 9, which is 1/3 times 3 raised to the power of x plus 2. On the right side, we can rewrite 5x plus 5 as 5 times x plus 1. Next, let's simplify the left side. 3 divided by 9 equals 1/3. We can rewrite 1/3 as 3 to the power of -1. Using the product rule for exponents, we can add the exponents when multiplying terms with the same base. So, 3 to the -1 times 3 to the power of x plus 2 equals 3 to the power of x plus 1. On the right side, we know that 2 to the power of 5 equals 32. So, 2 to the power of 5 times x plus 1 equals 32 to the power of x plus 1. Now, we have an equation where both sides have the same exponent, x plus 1. For this to be true, either the exponent equals 0 or the bases must be equal. Since the bases are different, 3 and 32, the only possibility is that the exponent equals 0. So, x plus 1 equals 0. Finally, solving for x, we get x equals -1, which is our answer. Let's verify our answer by substituting x equals -1 back into the original equation. To summarize, we solved this exponential equation by first simplifying both sides and using properties of exponents. We recognized that when two expressions with the same exponent are equal, either the exponent is 0 or the bases are equal. Since the bases were different, we concluded that x plus 1 equals 0, giving us the solution x equals -1. 1 equals 0, giving us the solution x equals -1. Let's solve the following exponential equation step by step. First, let's expand the term 5 to the power of 2x plus 2. This can be written as 5 to the power of 2x times 5 to the power of 2. On the right side, we'll express 0.0025 as a fraction, which is 25 divided by 10,000. Now, we know that 5 squared equals 25. Let's simplify the right side of the equation to 1 over 25 times 10,000. According to the laws of exponents, when we have terms with the same exponent, we can combine them. So, 5 to the power of 2x times 2 to the power of 2x equals 10 to the power of 2x. Also, 25 times 10,000 equals 100 squared. We can further simplify this equation. 5 times 2 equals 10, so we have 10 to the power of 2x. And 1 over 100 squared can be written as 100 to the power of -2. Using another law of exponents, we can rewrite 10 to the power of 2x as 10 squared to the power of x, which is 100 to the power of x. So we have 100 to the power of x equals 100 to the power of -2. When we have the same base on both sides of an equation but with different exponents, those exponents must be equal. Therefore, x equals -2. Let's review the key rule we applied in this solution. When an exponential equation has the same base on both sides, the exponents must be equal. This property of exponentials is essential for solving this type of equation. In conclusion, We solved this exponential equation by properly expanding powers, combining terms with the same exponent, and then comparing the exponents when the bases are equal. The solution is x equals -2. Let's look at this example. We need to solve the equation 1/49 raised to the power of x minus 1.5 multiplied by 7 to the power of x equals 7 to the power of 4. This problem requires us to apply the rules of exponents carefully. Let's solve this systematically. First, let's simplify this equation by rewriting 1/49 in terms of 7. Since 49 equals 7 squared, 1/49 equals 7 to the power of -2, so we can rewrite the left side of our equation with this substitution. Next, we'll apply the power rule for exponents. When we have a power raised to another power, we multiply the exponents. So 7 to the power of -2 raised to the power of x minus 1.5 becomes 7 to the power of -2 times x minus 1.5. Simplifying, that gives us 7 to the power of -2x plus 3. Now we can combine the exponents since we're multiplying the same base. When multiplying powers with the same base, we add the exponents. So 7 to the power of -2x plus 3 multiplied by 7 to the power of x equals 7 to the power of -2x plus 3 plus x, which simplifies to 7 to the power of -x plus 3. Since the bases are the same on both sides of the equation, the exponents must be equal. This gives us the equation -x plus 3 equals 4. Now we can solve for x. Subtracting 3 from both sides, we get -x equals 1. Finally, multiplying both sides by -1, we get x equals -1. Let's start with our problem. We need to solve for x in the equation 27 to the power of x minus 1 plus 81 to the power of x, all divided by 3 to the power of 3x equals 4/27. Our approach will be to simplify the left side of the equation by expressing everything in terms of powers of 3. First, let's rewrite 27 and 81 as powers of 3. Remember, 27 equals 3 cubed, and 81 equals 3 to the 4th power. Next, we'll expand the first exponent. 3 times the quantity x minus 1 gives us 3x minus 3. Now, let's split the numerator to make it easier to apply the division of exponents. We can rewrite this using the laws of exponents. When we divide exponential terms with the same base, we subtract the exponents. For the first term, we can rewrite it as 3 to the power of 3x times 3 to the power of -3 divided by 3 to the power of 3x to the power of -3 divided by 3 to the power of 3x. For the second term, we're multiplying 3 to the power of 4x by 3 to the power of -3x. Now, we can simplify both terms. In the first term, 3 to the power of 3x divided by 3 to the power of 3x equals 1, so we're left with 3 to the power of -3, which equals 1/27. For the second term, when we add the exponents 4x and -3x, we get 3 to the power of x. Let's solve for 3 to the power of x. First, we'll move 1/27 to the right side of the equation. Now, we can combine the fractions on the right side. For -1 equals 3, so we have 3/27. Let's simplify this fraction. 3 divided by 27 equals 1 divided by 9. We can rewrite 1/9 as 3 to the power of -2. Since the bases are the same, the exponents must be equal. Therefore, x equals -2. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.